Today's episode is sponsored by the new Refrigeration differential pressure monitor from Westermeyer Industries. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace the filter? Wait too long to service the filter, and you could end up with nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The new Refrigeration RDP-01 differential pressure monitor is available now with Westermeyer Industries. To find out more, email sales@westermeyerind.com. Once again, that's sales@westermeyerind.com. Look for the new pressure differential monitor, available now.
I wanted to take a quick minute to talk about one of our sponsors that make this podcast possible, and that's Parker Sporlan and the Catch-All Filter Dryer. Do you know what can reduce system efficiencies and reliability within your refrigeration system? If you answered contamination, you are correct. Sporlan Catch-All dryers have been around since 1947 and have been perfected over the years to capture water, acid, solids, debris, including sludges and varnishes. For best practices, change the catch-all filter dryer if any of the following occurs. Initial system install, when a system is open for service or repair, when excessive pressure drop of 5 psi across the filter dryer, when the see-all sight glass indicates water is present, when doing a T1-1 acid test kit says there's acid present, during a compressor burnout cleanup, and following a successful burnout cleanup. To find out more information by downloading Bulletin 40-10 from Sporlan.com with all the catch-all filter dryer information. Thanks, guys. Enjoy the episode.
But again, that's a complex question with multiple answers. And so you just kind of have to use your best judgment. There's no, in my opinion, again, based on what I've seen, there's no real reason to use a VFD during the summertime because, you're just going to wear the motors out. You got the VFD is running. I would switch over to bypass. If you have a problem, you can go in there, you can look at it.
Makes sense.
So if you had the DVDT, you had the grounding rings, you had a short run, that's when you'd maybe reconsider taking it out of bypass and basically just running it through the VFD, knowing that you do have all those things in line, to save the motors and save the VFD.
It is, because what you have to look at is the things that you can't really tell. If you have a 80, 90 degree day, if you're in Chicago or if you're in Dallas and you have, it rains or a cool front comes through and the temperature goes below 70 degrees and the VFD starts slowing down to even 55 hertz and it's just overnight for 6 or 8 hours, you have actually saved a lot of utilities compared to running it in bypass all night long. And so it's a case-by-case basis. Now, if you go back over to bypass mode, it's been my experience that the only way to control it in bypass is to drop contactors in and out to control your pressure. So you have to understand that every time a contactor kicks in and brings a motor online, any motor, a 3-phase induction motor, when that motor kicks in for the very first time, across the line is pulling anywhere from 6 to 8 times its full load amps in a short amount of time, milliseconds, to get going. And so NEMA has a start-stop cycle count. So if you knew the horsepower of your motor, 1 or 100 or 500, NEMA will say you can only start that motor so many times per hour. Now, if you look at HVAC world and you got horse and a half motors, no one is controlling the start and stop cycles on those motors, period. If the pressure goes down, then you're going to drop a motor out. If the pressure goes up, you're going to bring a contactor in. So those contactors could be slamming a couple times, more times per hour than you really should. Every time that contactor comes on across the line, you're heating up the motor internally, and you're also putting a lot of current through it, and you're damaging the motor just a little bit. So if you overcycle a motor through a set of contactors because you're trying to control pressure, that is going to that's what's killing your motors long term. If you didn't even have a VFD at a store and you're only doing it through your contactors, that's how you're maintaining pressure. If your control algorithm is not what I would call smooth, and you have one motor that is cycling on and off to maintain your pressure, that motor is going to fail the first because it's getting hammered probably many more times than it's rated for start-stop cycles. And every time you turn that contactor on, you're taking a day of life off that motor, if not more, and that motor's going to fail. But so you have to be careful with your overall control scheme of how you're looking at pressures, your dead bands, your instead of saying 140 psi is my hard limit to what I drop a contactor out, you need to say, well, 140 pounds all the way down to 130, and I don't want that motor to come back on unless it gets up to like 150, 160. So it's not constantly cycling on and off with just one set point. There's like a band that it's operating in, so you can make sure that your cycle count is much more forgivable over a 1 hour period, or you're just going to burn the motor out.
Well, one of the things I was taught is, any kind of, contactor, if you contact, Eaton or whatever, they're going to tell you that, their contactors are made to not exceed either, some manufacturers are different, anywhere from 6 to 10 cycles an hour, because of that. Your thoughts? You agree?
I agree with what we've done over time is when you cycle that contactor on and off, then the contactor company is going to look after the contacts inside the contactor. So you have the OEMs will use a cheaper version. It's called a definite purpose contactor. That's about as cheap as you can get, and then you can step up to a real 3-phase contactor. And so what we've done is we've gone to an ABB brand. It's called AF. It's just a family of contactor. Everybody makes a good contactor. There are good ones and there's cheap ones. And we've gone to this one because it has a electronic universal coil. It goes from 90 to 230 volts. So you can use it inside the VFD panel for 120 volt stuff. You can use it in a condenser control panel that has 208 volts for your coil voltage. You can use it for 230, 240, and it has an electronic coil, so it won't chatter. So if you have a brownout at the store and the voltage goes down to 90, 80, 70, it will turn off and it won't chatter, bang, bang, bang. It'll either be on or it'll off, and it has it has a good quality contacts on the inside of it. So what you're looking at when you were talking about the contactor company 6, 8, 10 times per hour, every time it turns on, then you're looking at the 6 to 8 times of the motor amps are going through those contacts, and those contacts may be general purpose, they may be silver lined, different coatings on them, and every time you turn it on, you're going to have a little tiny pit in them. Now, it may take thousands and thousands of those little pits, but eventually you may see a resistance built up on one of those contacts inside the contactor. Um, what I do as a general rule when I'm talking to technicians or contractors and they're having strange problems, they're having strange overcurrents, they're having earth grounds, ground faults, weird things that can't be explained, then I always have them power down and push the contactors in with their hand or screwdriver, and I have them measure A to B across the top and bottom, all 3 phases, L1, L2, L3, down to T1, T2, T3, and make sure they're all 0. Sometimes you can get a little bit of arc built up, and you'll see 0, 0, and 10 ohms. And if you have 0, 0, and 10 ohms, you know that you've got crap built up on the inside. And so at that time, you need to replace all those contactors, because if they're all the same age, they've seen all the same abuse, they've seen all the same cycle count. If one of them's bad, the other two are going to go bad. That's how I look at contactors inside the VFD panel, as well as the condenser control panel. I have a mash them in, check it top to bottom. Another thing that I've seen is we'll lose we lose about a dozen control power transformers a year in VFD panels, and they'll burn up. And so the contractor, the technician will replace them. And a month later, or 2 months later, or 3 months, it'll burn up again. And so when a 120 volt transformer burns up inside a VFD panel, then more than likely there's a 95% chance, you could have a lightning strike or something, awful happen on your power, would kill it. But more than likely what's happening is the coils of the contactors inside your VFD panel are shot. And so the resistance on the coil, as it goes down and approaches zero, will pull more and more current, more and more amps. And what it'll do is it'll suck more and more amps out of that transformer and burn it up over time. And they'll replace it, not even knowing that their contactor is pulling too much. So if you look at your control power voltage, it's 120 volts. So if it's going to a contactor, if the contactor between A1 and A2 is 120 ohms, then Ohm's law, 120 volts divided by 120 ohms is 1 amp. That's how much current it's going to suck or take. If you have 240 ohms, it's going to pull a half amp. But so, the transformers are typically 1, 2, or 3 amps. They're not very big inside a VFD panel on the HVAC stuff. And so if you look at your coil ohms and they're getting below 250 ohms and they're approaching 50 ohms, but they're still operating, they're pulling way, way too many amps out of your control power transformer, and they're just loading down the system and going to burn it up. I'm not sure how I got off on that, but we were talking about contactors and cycles. But you are correct. All the contactor people, they don't want their contactors to be cycling more than 6, 8, 10 times per hour, because if you look at that over time, you're just going to beat the crap out of the contacts on the inside of it and create resistance. And once you have 1 or 2 or 3 or 4 ohms of resistance built up on any contactor anymore, I'm worried about the 3-phase that's going out to your motors. If the motors are 20 ohms, 20 ohms, 20 ohms, A to B, B to C, C to A, now you got a motor that's 20 ohms, 20 ohms, and 25 ohms, and you're going to have a difference of current out there, and now you're going to either have some sort of overcurrent or phase that's imbalanced.
So, Matt, I wanted to ask a question right here, because you brought up that control transfer thing. So out by me, especially when we start getting into more rural areas, I see massive amounts of control transformer failures. Like, I'm talking, we have stores where every time a storm rolls through, 3 out of 4 cabinets are dead. And every time it's contactor failures. So, and I want to say 80 to 90% of the time, it is the bypass contactor. Why is that? Is correct. Why is it always the bypass contactor that burns out the coils?
I don't know exactly. I'd have to. I need to put some more thought into it, because out of the 10 transformers that we've had burn up this year in 10 months on Danfoss VFD panels, 100% of the time it's been what we call M3, the bypass contactor. The coil has gone way, way, way down, sucked up too many amps, burned up the transformer multiple times until we caught the coil ohms. They've replaced M3 and everything's back to normal again. So I don't know why the bypass contactor. Pardon?
Yeah, this summer I've had 17 of them. But I know exactly where to check. Yeah. I mean, as soon as as soon as it's burnt up, I mean, I know I'm going right to the bypass contactor and opening it out because I've had guys do
Yes.
that. I've had my guys go there and they could replace the transformer. They fire it up, everything's fine. It goes to the bypass, boom, transformer blows up because they didn't check the bypass
Yes.
contact.
Now, a lot of times, surprisingly, and these on the ones that I've seen fail, I don't know why this is. It may have been a cost deal, but every control power transformer, every single one of them, should have two primary fuses on, let's say, the 460 volt, but they should also have a secondary fuse for the 120 volt. And many times I've seen, like on the Danfoss VFD panels, I've seen many of those have the two primary, but not the secondary. And if you had the correct primary fuses and the correct secondary fuses, then that secondary fuse would blow before the transformer burned up and you could save yourself a lot of grief. Now, unfortunately, many times I've seen where uh, the 1 amp fuse blows, they replace it with the two. If the two blows, they're going to put a three in it, and they just continually push up the size of the fuses either on the input or output side. And what you're doing is just going to burn the transformer up. So there's a chart. You look at the input voltage 460, output voltage 120, the VA rating, and it will tell you the input and the output ratings or fuse sizes. TRM3 on the output side, time delay, um, your 460 volts on the input, the ATQ DR4, whatever. So, the fuse sizes is pretty hard and fast. You can look at the chart and tell what fuse is blowing, the primary and the secondary. But most of the transformer failures I've seen this year did not have secondary fuses on them. And again, to go back to your question, that's a really good question. I don't know why the bypass contactor would be the one that fails the most and kills those transformers, but that's what I've seen as well.
So, we had an instance, I called, once again, I called you on it, where basically the NIDEC was going off, I believe on, I want to say over or instant current alarm. And basically if there,
Instantaneous overcurrent, yes, IOAC.
that's it. So I've seen this happen before, and I never knew that this happened. But basically, if the bypass contactor kicks out instantly and brings on the VFD, and if there's there's no delay, like if there's no time delay, no physical time delay, and it'll basically do that. Why is that?
There's a couple of reasons for the instantaneous overcurrent. One of the most common one is you have what it's looking at is it knows its own current rating. Let's say it's a 10 amp drive. It knows that approaching 15 to 20 amps, something bad has happened in the output, and it's looking at the current going up. So in the millisecond range, it will see 10, 11, 12, 13, 14, and ramping up, and it's going to go to 20 amps, and it's going to do something bad. So it will trip out on that IOAC instantaneous current because it wants to prevent something bad from happening. So the instantaneous current can happen for a couple of reasons. One of them could be a motor that is going bad. It's not a bad motor, and it will run fine in bypass, but you have a motor that is 10 ohms, 10 ohms, and 5 ohms. Part of the winding has broken down, and again, it runs fine in bypass because bypass doesn't care. But in the VFD world, it will see that as an imbalance, and it will pull more current. It will see that as an instantaneous overcurrent. It will see moisture and seal tight. Moisture, if you left the condenser control panel open or there's holes in it and you get condensation and moisture on the wires of the cable, the three phase, then it will see that as a short circuit and trip out on overcurrent or instantaneous overcurrent. It could be a loose wire. If a loose wire vibrates, it will arc, between the wire and let's say the copper or the screw, and that arc is a high voltage arc. It will see that as an instantaneous overcurrent as well. And so there's several it's trying to tell you that there's something going on out there, either in the motor or the contactor or the cable, and it's trying to protect itself and say, hey, something bad is happening out there in the current world. So if you had the VFD wants to start off, um, and it wants to control its output from zero speed or zero voltage to, let's say, 460 volts on a 460 volt drive. And so what it does not like is, in multiple motor applications, if it cranks up on 5 motors and you have the 6 motor drop in and out, then that spike in current and voltage can, if the VFD is not sized correctly, can get back on the VFD and cause the instantaneous overcurrent, um, as well. The VFD, you should never, as a general rule, you should never have a contactor on the output of a VFD drop in and out for any reason whatsoever. The only exception that I can think of is, um, we have thermals in a lot of our inverter duty motors, and the thermal wires will trip out, um, at a predetermined temperature inside the VFD. So let's say that the insulation is going to melt at 300 degrees Fahrenheit. Well, the thermostat inside is going to trip out at 250 to 280 because it wants to make sure that the insulation doesn't melt inside the motor, so it will kick out. So if you have coils that are completely plugged up and it looks like cardboard, there's no airflow, and that motor's running real slow speed, there's no airflow, and the motor temperature gets up high enough, that thermostat will trip inside the motor. We took those thermostats and took them to the coils of each of its motor contactor. So if the motor overheats in the middle of summertime, it will drop out its contactor. And we knew that that was not the best ideal situation for the VFD, but we were trying to protect the individual motor from burning itself up. And so that's another reason we put in the 10% service factor. So when that motor kicks back on, hopefully it's the only motor that does it, then it would not overcurrent or overamp or cause any problems back on the VFD. Did that answer your question, or I go too far down the rabbit hole?
No, that's fine. No, because like I said, I was told that, basically if the motor's still spinning, it's, like if it went from bypass, back over to VFD, basically that motor is still inducing voltage, potentially down the line. Because I mean, I know anyone listening, if they've, trying to check voltage after they shut something down, and that it's windy outside, and basically that condenser fan motor is still spinning, and you go to check voltage, on there, you will get, some sort of voltage coming back, and you're like, well, wait a minute, I have everything pulled. What the hell? And that's basically caused from the the magnetic induction that's spinning that motor and basically inducing voltage back through the contactor. Yeah,
that is exactly right. It's called back EMF. Um, when I have contractors and technicians, when we're ohming out contactors, and they get to the contactors inside the condenser control panel, and they ohm them out top to bottom, and I make sure they're all zero. Then the next check, when we're having a random instantaneous overcurrent or overcurrent problem, some sort of weird VFD trip, I'll have them ohm out the motor, A to B, B to C, C to A. And if the motors are all the same brand and same model number, they should all be very consistent. 20 ohms, 20 ohms, 20 ohms. What you're looking for is an anomaly. 20, 20, and 15 ohms. That tells me that part of the winding of that motor is starting to fail or short circuit, and that motor is going bad and needs to be replaced, especially if you're using a VFD. So when you're ohming out a motor, it's exactly what you said. If you're ohming it out and that fan blade turns at all, like 1 RPM, it will turn the motor into a generator, and that voltage will come back into your meter, and your ohm reading will just go off the chart. It'll be 100 ohms, it'll be 0, it'll be meg, it'll be 10 ohms if that motor is turning, because when a motor that is not powered up, is rotating, then it turns into a generator, and that generator is taking voltage and putting back on the line. and that's not good on VFDs. If you had enough potential, if you introduce raw 460 volts back into the output of the VFD, you're going to blow the output transistors. Now, if the motors are just barely turning, then that voltage is not high enough to cause problems back inside the VFD. But if you change from bypass and flip over to VFD mode, and your motors are still hauling ass and moving, then the VFD enables and it gets a run command, the first thing it's going to see is I'm supposed to be at 0 volts, 0 current, and yet I see all this kind of disturbance out there. It's going to trip out on instantaneous overcurrent or ground fault or earth fault because the motors are turning, and it doesn't expect that.
Yeah, and that's why the guy I was talking to, we were doing the programming for it, and he's like, you need to make sure there's some sort of time delay in there, whether it be through the program or whether it be a physical time delay to alleviate that from happening. Before I forget this question, because I've been meaning to ask you this, because I've been asked this question and I don't know the answer. I don't know how many times I've been asked, because you don't get straight 480. Coming out of the VFD, because I want to know what that voltage is supposed to be or how to figure that out. First, if you can start off by explaining what pulse width modulation is, and then basically work off of there, and then give us why how to get an expected voltage, basically.
So. And again, that's a complex question that could go on and on. When you have voltage coming into a drive, whether it's 230 or 460, the very first thing that happens is it will take that three-phase and it will rectify it into a DC bus. So 460 volts into a rectifier in the three-phase world is the square root of 2, which is 1.414. So 460 volts times 1.414 will give you about an average of 650 to 650 volts, 650 to 675 volts DC. So now you have a VFD that has a heartbeat or a pool of energy that is 650 to 670 volts. If you have 480, it's going to start pushing 700 volts. If you have 500, you're going to have over that 700 and something, 710, 720 volts. So now you have this pool of energy that is 650 volts DC. And so then you have on the output of the VFD, you have really fast transistors called IGBTs, insulated gate bipolar transistors. They're just really, really fast relays. And
Matt,
those transistors are going to, yes.
One second. Kevin just informed me that he has to skate. He's got an issue with a store. So okay. I want you to continue, but I just wanted to, bid Kevin adieu and.
Okay, Kevin, it's good to meet you.
Nice to meet you too. Sorry, guys. Sorry, Matt.
That's right. I've been there many times. Good luck.
Take it easy.
Talk to you later, Kevin. All right. Sorry, Matt. I didn't mean to interrupt you, man. I just, he texted me. He's like, I got DEFCON 1. I got to.
That's okay.
But go ahead, continue. I'm sorry. I stopped you at transistors.
All right. Well, I'll go back to one time I was sitting at my house and it was like 7 or 8 o'clock at night and minding my own business, watching TV. And there's a knock on the door and 2 electricians from a local plant came by my house and said, we've got a breakdown at the plant. And they said, do you mind going up there and looking at it? And what I didn't realize at the time, so, I grabbed my tools, grabbed my meter, we went to the plant, and it turned out to be an all-night deal. We were there till 7 or 8 o'clock in the morning. What I didn't realize at the time is they were afraid that if I drove my own truck, that I would have the luxury of us saying, I need to go back home, or this is too late for me. I'll be back in the morning. So since they drove, and it was about an hour away to the plant, I had no way of leaving the plant, so I was forced to work all night long.
You're going to stay until you figure this out.
Yeah.
Hey guys, I want to take a break and talk about Westermeyer, one of our other sponsors. Today's episode is sponsored by Westermeyer Industries, the leader in oil management and pressure vessels for the commercial refrigeration industry.
So the output transistors are firing at a certain rate, and that's called the carrier frequency of the VFD. And they're firing at typically like 4,000 times per second, 4,000 hertz, 4 kilohertz. They can go up to 6, 8, 10 kilohertz. They can go down to 1.5 kilohertz. So it's taking that 650 volts and it is pulsing it out to the motor. And so a really, really short burst or medium burst or long burst, the motor will look at those bursts, which is pulse width modulated. So when you look at it on the scope, you see a whole bunch of square waves in front of you, but the transistors are firing it in a way, in a pattern, that the motor sees this as 0 to 460 volts. If it's getting a short pulse, it thinks that's 0 volts. If it's getting a full pulse, it thinks that's 460 volts. And then it does it in a way that it has a man-made sine wave going out to the motor. It's not a clean sine wave that the motor wants to get, like in bypass mode. And since it's not a clean sine wave, then the highs and the lows of this sinusoidal waveform is what's killing the motor long term. And so if you have a meter and you put it on the output of a VFD, then unless you have a really good true RMS meter, you're going to read roughly what it's putting out. Your meter may say 250 volts. It may be putting out 200 volts or 300 volts. There's monitoring parameters inside the VFD that will tell you exactly the voltage that it's putting out. What you're after when you're looking at the VFD output is, again, consistency. So if your meter, if it's a $10 Radio Shack meter or a $300 Fluke 87, what you're after is consistency. So if the VFD is putting out 60 hertz or 40 hertz or 30 hertz and it's rock steady, your reading between A to B, B to C, C to A should be consistent. If it's something weird, then that's when you need to start getting worried about what the VFD is going. Now, here's another tech tip that I see all the time. A VFD, since it rectifies the input voltage, three-phase input into a DC bus, you can drop a leg, blow a fuse, and it will still produce that DC bus, and it will still produce three-phase out to the motor, and you can still run the motor.
Sometimes, no, I just want to let you know, because I had that exact same thing happen, and the only thing that was different about it is when I lost that one phase, is that the pressure transducer was actually reading off a couple pounds. Because actually, once again, I called you because I was trying to figure out how to basically put an offset in the Commander SK, and you had told me how to do it, and I don't know, I forget what happened. I was like, well, something doesn't seem right, it was weird because like they were spinning fine, they were spinning as fast as what they should, but I had lost one of my legs on the incoming.
Yeah, as a general rule, the way I look at it, or the way I explain it, is if you have all three legs coming into the VFD, they're sharing the power, 1/3, 1/3, 1/3. So if you lose a leg, now you're down to two legs that are sharing half each, a half and a half. So you can actually have a VFD that will run all fall, all winter, all spring, because you're not pulling as many amps, the load's less. But then when you get above 45 to 50 hertz and you start having overcurrent trips, then you may not have realized that you lost one of those fuses 6 months ago. And now that you're going up to 45 hertz, it's wanting full amps and you can't provide it because you got two legs going to it. Then you'll start getting random overcurrent. And here's the key is out of the 100 phone calls I've had, I'll say, when do you get this overcurrent? They go about 1 o'clock in the afternoon, and I go, okay, I know you got a blown fuse because at 1 o'clock the sun's out and your speed goes above 45 hertz. And I have them run a history on VFD speed, and they go, yeah, it goes up to 40, 45, 50 hertz, and then faults out. And it goes to bypass. And I go, yep, you've blown a fuse. You need to check your fuse. And they go, how in the world can this thing run without a fuse? Like,
But it's
well,
spinning.
maybe.
It's still spinning the same speed. What the hell? They can't. I can't have lost the fuse, right? That's crazy.
And there's another. I could go on and on. There's another tech tip when you install a VFD or replace a VFD. Then it's very important that you look at motor direction, because you can have the fans, motors, any industrial HVAC, doesn't matter. They'll run in one direction in bypass mode, but you could get the phasing completely backwards in VFD mode, and you flip the switch and your motors will run backwards in VFD mode. So you have to be careful of that. Watch that when you hook up a VFD for the first time or replace it. You never know which direction that thing's going to go in.
When we took over one of our accounts, there was a bunch. I must have probably fixed, I don't know, I probably about 10, 7 to 10 different stores where, because they run in VFD predominantly most of the time unless there's an issue, right? So, I would get there and running fine, and then all of a sudden, certain time of the day, for some odd reason, we'd end up going to the bypass, and then the whole rack would shut down. Well, it's because the damn, when it went into bypass, the damn thing was spinning backwards. Maybe by the time we got there, kicked back out of bypass, kicked back into VFD. I was like, well, what the hell? It's spinning. And it was basically because because the drive is what dictates the direction, whether you put it in forward or reverse, right? And the only way to actually change that is it the inlet of the VFD, correct? Or the
I'm sorry, not the inlet, but the outlet.
Yeah, the outlet, yeah.
Yes, because since it's a man-made three-phase voltage, then you're going to swap two legs on the output of the VFD, either at the VFD or at the top side of the VFD output contactor. I've had many times where, inside the VFD panel, it's either bypass contactor or VFD contactor, and they come together, and then the output of that Y goes out to the condenser. So I had a contractor call me. This happens about once a year. They go, well, it's running fine in bypass, but it's running backwards in VFD mode. I said, well, you need to flip two legs. And they go, okay, got it. I'll call you back. And then they'll call me back and say, well, now it's running right in VFD mode, but it's running wrong in bypass. I go, did you flip two legs? And they'll say, yeah, we're flipping two legs at the disconnect inside the condenser control panel. I go, no. I go, you're fixing one and screwing up the other one. You need to go back to the VFD panel and do it at the top side of either the VFD output contactor or the bypass contactor, and then you get it. I also get about not as many now, but I get about one phone call a year for the last 10 years where they'll break shafts off of a motor. And about the number one reason for breaking a shaft on a motor, because they'll be upset about it. They go, it broke the shaft off, and you're dang lucky that these blades didn't go through the coils and I lose refrigerant, because this would be on you. And I go, well, you need to look at this. And what happened 100% of the time is they had it wired up backwards, and this thing was in VFD mode, and it was going let's say the right way, and it was going 60 hertz. And for some reason it faulted out, and it immediately went to bypass, and bypass was going the wrong way. So we went from full speed clockwise to full speed counterclockwise in less than a half a second. And that will spin a shaft off real easy. So I'll tell them, I said, you need to look at this and make sure that it's going the right direction in VFD mode and bypass mode. And I said, more than likely, it's running backwards in one of them and it's tripping out, because when you trip out on the VFD, it flips over to bypass like instantaneously. There's no time delay. And I would say 98% of the time, they never call me back. And that's what's happened, is they've realized that one of them was wired up backwards, and they were tearing up shafts themselves, and it wasn't my fault.
So I love those. Like, it happens all the time where, a guy will call me up and have a question. And, one of the other things the guys hate about me is, like, I never give a question. I never give an answer straight up. It's always a question with a question. And then it's like, oh shit, I got it. And then I'll never hear back from him for like, like 3 or 4 days later, I'll call him up. I'm like, what did you ever find out? He's like, no, never mind. Don't worry about it. Because he realized he did something or found something that he probably should have, caught before he actually called me. So,
I had a technician earlier this week called, and he said, my discharge pressure's not working. And I said, what does it say? And it'll say, it's just like 0 pressure. I go, what's the voltage on it? He goes, 2.5, 2.7 volts. I go, well, that's right. I go, are you sure the polarity is right? The common on common, and the voltage is on the analog input. He goes, well, I'll check that and get back a hold of you. And he never called me back, so I knew I knew that you had the 2 wires backwards. And so most of the time, like yesterday, I had a contractor call. He's starting up a new store, a new VFD panel, and he had some Novar boards that were installed on the VFD panel. So they had to do a download to recognize the address of the new boards. And he said they're not communicating. None of the 4 VFD panels are communicating. And I said, you got the download in there, right? He goes, yep. I go, well, I know they're wired up because I checked them before they left the panel shop. And I go, the only thing that I can think of, and he checked the addresses. The address was correct. I said, on the download form, I go, do you still have the download form that has to be turned in to the mothership? He said, yep. I said, the only thing I can think of is they're going to look for those boards either on channel A or port A or channel B or port B. I go, my guess is they're looking for them on port A, and you've got them landed on the comm wires on port B. And he goes, let me check that. Never called me back. And so I go, well, that's what it was.
So one tech tip for you guys. So, because I had this happen, and I on the NIDEC, the M400, I basically had, it was when it got real cold. It was that cold snap that Texas had, where basically we actually had snow that stuck around, longer than 3 hours. We actually had it for like 48 or 72 hours where it stayed around. Like, we actually had inches, like everything shut down. And the guy called me out from, I want to say down. Yeah, it was down in Rio Grande Valley. And he's like, Brett, my drive is saying that my pressure is 215, but my EMS system is saying that it's 120, 110, and my fans are all the way up to whatchamacallit, all the way up to like 60 or 60 hertz. And so we went through and made sure it was reading the right pressure. The EMS was right. The pressure on the pressure transducer was reading incorrectly on the NIDEC on the M400, and he checked the transducer, checked the program, and the program was correct. And it was the weirdest thing. And I have this thing called an interpolator. Basically it plots, on anything linear, it plots the beginning and the end. So if you're 0 to 500 PSI and you're 0 to 5 volts, it knows that at 2.5 volts, if you're getting 2.5 volts, you put that in there and it'll spit out what pressure you should estimately, get, right? Just to make sure that it's, that's lining up properly. You can do this with sensors, pressure transducers, anything that's basically linear. And it wasn't lining up. And I'm like, but it's programmed right. Like, that was the weirdest thing. And I'm running out of ideas. It's on the weekend. And I'm like, I was just about ready to give up. And I was like, man, just for shits and giggles, I said, basically, program the VFD wrong. Once you program it wrong, cycle the power. Cause on the M400, you had taught me that basically you have to drop the power for, to some of the settings to get in. And then turned it back on, and then it was reading the wrong, basically wrong pressure again, which is fine because that's what I figured it was going to do. And then I had them reprogram it back to what it was supposed to be. And as soon as you did it, it freaking took off. Like it went back to actually reading correctly. And I had never seen that like, because if it's programmed wrong, obviously it's gonna read the wrong pressure, right, based off of what it is. But we had to program it wrong and then turn off the power and then program it right to get it to read right. And I've never seen it's the first time and only time I've ever seen that thing happen.
I've seen that happen a couple times to me. It doesn't make any sense. When the VFDs, especially when they're in smart mode, when they have like the refrigerant program running inside them, the Danfoss, ABB, Emerson, doesn't matter. Then as they're operating, they're kind of learning as they go, and they're looking at pressure, looking at temperature, and they're making decisions better and better because they've got a history. And so the PID loop on the inside of it will fine tune, and that way you don't have any highs or lows. And so they kind of learn over time. But so sometimes when I'm at a loss for words, I'll have the technician or contractor power down, wait for the lights to go off on the VFD, wait 30 seconds, and power back up. And what that does is it cleans out all the registers, and all the registers are at zero. And so now I'm starting off with a blank slate, and you power it up, and then it's got pressure, it's got temperature, and it starts learning as it goes. And sometimes that will clear up some of my mistakes. It may have a power glitch or a brownout at the store, and it's got a register that's locked, or it's got overflow, or it's got bad data in it. And by powering it down, you're cleaning out all those registers and starting over from scratch. So power cycles are always good for it. As long as you leave them down and wait for the lights to go off, because that could take 30, 40 seconds. Don't just take power off, wait 5 seconds and turn power back on. You need to make sure that VFD loses the lights on the display before you go back up.
Absolutely, because I mean, those capacitors will hold on to that voltage and keep that thing. That's why the display stays illuminated for 15, 20 seconds after you actually cut the power, right? So
Yep. And some of those are pretty healthy, and in our classes, take those capacitors and charge them up and leave them around on tables, and people would go pick them up, and it'll fry you pretty good.
So you brought up those classes a couple times. So when do you guys put those classes on? Are they virtual? Do you guys go to people's site? Do they have to come up to a Motion Industries facility?
No, I travel around and do them. So I live in Missouri, and so what I do, like for a given contractor or for a given, let's say, Walmart, then I'll contact the regional managers. So when I did it earlier this year, then I contacted the regional managers and I made a cycle. So I went into Tennessee, went down to Alabama, and went to Atlanta, Georgia, went up to North Carolina, came back through Charleston, Columbia, South Carolina, and worked my way back to home. And so instead of me traveling a long way to give one school, then some of these schools are in this particular case Walmart technicians only. Some of the schools will have contractors only. Some of the schools will have a mixture because we're looking at it's what's called open territory. So there's no technicians, and so the contractors will come to the school. And so I'll try, depending on how many people want it, how many people want to go to the school, then I'll make a tour out of it, and I'll be gone for 2 weeks or 3 weeks, and that way I can, on the way down to Dallas, I may pick up Tulsa and Oklahoma City, go down to Dallas, maybe go down to San Antonio, work my way back, and so it all depends on demand, and I just kind of set up the schools based on who wants them and where. It's kind of a case by case deal.
Well, let me know next time you're in the area. I'm sure we'd love to have you in some of the regions. In Dallas and San Antonio, Austin, Rio Grande. If you happen to be in that area. But
Okay. I mean, can I post my email address, and that way anybody listening can get a hold of us?
Absolutely, absolutely. We're gonna wrap up here. So any kind of information you want to give out, and so any of that technical documentation that you were talking about before, Matt, with some of the documents for the your I was gonna say your kids' initials, your the model numbers of the part numbers for those motors and stuff. Any kind of information I'll be putting up that I get from you, I'll put up on the Advanced Refrigeration Podcast Facebook group. But go ahead and give whatever information you'd like.
I can send all that information to you.
Go right ahead.
I'll give out our department email is hvacrmail@motion.com. So hvacrmail@motion.com. That will go to our entire HVAC group. And that way it'll go to what we call the inside sales. It'll go to me as well, which is I'm in field service, but that way I can get it, and that way you only have to remember one email address. And instead of giving out my cell phone, that way I can kind of filter through the emails. And I don't have any problems giving out my emails to people that have specific problems, but this might be the best way to get a hold of me.
Absolutely. Well, Matt, I'll speak for Kevin as well because he had to book out. But I really appreciate you coming on. I learned an immense amount of stuff. I really appreciate it.
Well, yeah, there's no, in this business, as you know, especially, I'm ignorant of the other side of it. The EMS and the refrigerant and the compressors. That's not my expertise. But as you know, to speak for the VFDs and the motors and the controls and stuff like that, there's no silver bullet. So when I'm in schools and training, and people will say, "Why does this fail?" Or "Why do I have problems here? Why do I have problems with this? Why do the motors work? The same motors work here in location A, but they fail every month in location B." And there's no perfect answer or no single answer I can give to that. It's a case by case basis. So as I've gotten older, I've learned that in order to give them the correct answer, I have to ask them questions, because many, many times the technician or the contractor doesn't know the information to give me in order for me to give him an answer or help him out. And so I kind of have to steer them in the direction and say, have you checked this? Have you checked that? Well, no, I had no idea that had any impact on it whatsoever. And I said, okay, so give them an idea, and then we'll try some out. Or if they have like 4 condensers at a store or whatever, then we'll try something out on one condenser. I'll say, give me your worst condenser. Where are the motors failing the worst? And then we'll figure out a solution for that one. And typically, if the motors are failing every month or two, then if the motors last 6 months to a year, then we'll know that we've done something correct, and then they can add that fix to other locations or other sites. So again, I'm not perfect, and I can't solve everybody's problems, but I've seen a lot. And since I'm in field service like you, typically I only hear about the worst things or the most problems. And I've created a database, and I remember a lot of what I see, and so we'll get there eventually.
Well, Matt, stay on the line. Guys, I appreciate you guys listening. Matt, once again, I appreciate you coming on and sharing all your knowledge with us all. Guys, have a good night.